When using the distributed FrameBuffer for data parallel rendering, the sort last compositing task is broken down and run independently per tile using a tile operation. Each rank owns some brick of data and renders it to the tiles it projects to. As tiles are rendered, they are sent to the rank responsible for compositing them, highlighted in yellow. The inputs to expect for each image tile are dependent on the data distribution, minimizing the compositing work on a per-tile basis. Once all inputs have been received, the tile is composited and sent to the display. The distributed FrameBuffer can also be used for image parallel rendering. Each rank renders a unique subset of the tiles in the image and uses a tile operation which expects a single input tile for each image tile. As before, tiles are composited asynchronously in parallel with rendering. More complex data distributions can also be rendered using the distributed FrameBuffer. In this example, we render a volume distributed among two ranks, and an isosurface which is replicated between the ranks to allow for computing shadows and ambient occlusion on the surface. Each rank will render the volume region assigned to it, and the portion of the isosurface contained in this region. The remainder of the surface will be used as a ghost region for computing shadows and ambient occlusion. The rendering work and compositing tasks for this scenario are identical to the standard data parallel configuration. Finally, the data can be partially replicated between the ranks to achieve better load balancing. In this example, each rank stores two bricks of data, sharing the rendering work with another rank. As in the standard data parallel configuration, we use a sort last compositing tile operation, with each rank responsible for compositing a subset of the tiles, highlighted in yellow. However, the actual rendering workload for a brick is distributed image parallel among those ranks sharing the brick. For example, brick 0 is rendered by both ranks 0 and 2 for the upper left and lower left tiles respectively, highlighted here. The rendering work for bricks 1 and 3 is distributed similarly. On the other hand, brick 2, which only projects to one tile, is only rendered by rank 2. When the rendering workload is not evenly distributed among the bricks, our mixed parallel configuration can provide better load balancing.